Hey everybody, this is going to be a quick video on function notation and domain and range because I will be out of class the next 2 days for testing. So I want to kind of go over these two concepts and make sure everybody is familiar with them and understands them, and that we don't have any questions about what is actually function notation and what is domain and range. So we're going to start with function notation and thinking of it kind of as a machine, okay? So a function can be thought of as a machine. All right. So that assigns one output to exactly one input. Okay. That assigns one output. That did not space out like I thought it would. One output. Get it to work. There we go. One output to every input, one output to every input. So the key is with functions, as we know, we do not repeat input. We do not repeat our X values, okay? We do not repeat our X values. All right, so this is kind of the breakdown of function notation. You see a F and then parentheses with an X inside, and then it usually equals some type of equation, 3x plus 4, 1/2 x minus 8, it just depends. We read this as f of x. So when you see this right here, we see this as f of x. That's how we say this. And there's some different parts that it means, okay? F is our name of the function. This is our name of the function. How we are naming the function is f, okay? So it could be f of x, it could be g of x, it could be h of x. Those are usually the most common ones we see, but that's our name of the function is what f is, okay? It's telling us what we're calling it, because we use these a lot. We have lots of different data, okay? All right, I don't know how that turned blue. I had purple. Let's see. All right, the name of the function. All right, x. Whatever we see for x, this is the number to plug into the function. Okay, that's what x is. All right, f of x, this is a lot to type, but f of x means the output of the function f when the input is x. All right, so think of it as our y, So again, this is just another funny, fancy name for y, okay? That's basically what this is. It's a fancy name for y equals. And so basically how we read this is the output of the function when the input is x, okay? Same thing as y, it's our output. All right, and last but not least, 3x plus 4 is our actual function. This is the actual function that you are using, okay? So this is function notation. This is like what our little function machine means. So we're going to look at a couple examples together and make sure that we can understand these and these make sense, okay? So if you need to write this down, you can pause the video. So our examples are going to start here. We're not going to do all of these, but we're going to start with, we have four different functions. We have g of x, f of x, h of x, and j of x, okay? And technically h of x is a function. It's just not actually, there's two of these that are not linear functions. F of x and h of x are functions. They are just not linear functions. And it's very important to keep that in mind, okay? But the other two are linear functions. So we're going to do A, and A says g of 10. So here's how I read this. It tells me choose function g. So I'm using g of x equals negative 3x plus 1. And it says g of 10 means plug in 10 for wherever we have an x. So what this means is g of 10 means I'm going to do negative 3 times 10 plus 1, which is going to give me negative 30 plus 1. So g of 10 equals negative 29. And my answer is negative 29. We're not trying to solve for x here. We're not trying to solve for g. We're literally just trying to evaluate this. That's why we see the word evaluate and not solve. That means we're plugging in and we're simplifying. We're not solving it for a specific value. All right. So letter B says f of 3, f of 3. So what that means is we're using function f. So I'm using f of x equals x squared plus 7. And f of 3 means we're going to plug 3 in for x. So we're going to evaluate this function when we put in 3. So I do 3 squared plus 7 is 9 plus 7, which is 16. So 16 is my answer. I'm going to do one more for you, and this is a tricky one, and that's going to be f of h of x. We're going to do this one. So what this means is we're going to plug in x into the function h, and then we're going to take that function and plug it into f. So I have f of x equals x squared plus 7, and then h of x equals 12x. So it's already set up as h of x, so we're going to take this, basically think of it as saying this is what we are plugging in for x for h, okay, or for x for f, okay? So we're taking this whole thing and we're going to plug it in for the x here. So f of h of x is equal to 12x divided by x squared plus 7, which is 144 divided by x squared plus 7. So f of h of x equals 144 divided by x squared plus 7. So this is how we evaluate functions. I'm not going to give you anything like f anytime soon, but you are going to see things like c and d, and even h. H is kind of backwards. H says find x, so find the x if g of x equals 16. So that tells me I'm using g of x equals negative 3x plus 1, and they're telling me, what they're asking me, find the input x, so find this x when the output is 16. So this is saying this whole thing is 16. So I have 16 equals negative 3x plus 1. I'm going to subtract 1 from each side. I get 15 equals negative 3x. Divide each side by negative 3. X equals negative 5. So my input was negative 5 when my output was 16. So this is one where I actually was finding the value of x, okay? So it depends on what they give you. Normally, we're just going to ask you to evaluate like A, B, C, and D. These 4 you need to be familiar with, okay? And you are going to see some H and some G, but we'll practice those more as we get to them. All right, so let's apply this. What we're going to do is we're going to take this and interpret a function. It says the swine flu is attacking Porkopolis. The function below determines how many people have swine, where T is the time in days and S is the number of people in thousands. So we need to find S of 4 and then talk about what that means. And then we need to find what is T when S of T equals 23 and what does that mean? And then we need to graph this function. Okay, so this is a real world problem. Right now, just by looking at this, I know this is not a proportional relationship because it starts at negative 4. Okay, so what we're going to do to start is we're going to plug in 4 for T. So S of 4 means we use function S, and we're going to put 4 in for T. So 9 times 4 minus 4 equals 36 minus 4, which is 32. So, and again, this is in thousands. So after 4 days, 32,000 people have the swine flu, okay? So it's 32, and then we say that is in thousands. All right, what does S4 mean? What does that mean? I just said it, that after 4 days, 32,000 people have the flu. Okay. All right. C is find T when S of T equals 23. So this is kind of an opposite problem. We're finding T. We're finding what is the input to get an output of 23. Okay, so what we're going to do is we're going to set it equal to 23, and we're going to do 9 times t minus 4. We're going to solve this for t, and we're going to get t to get our answer here. So we're going to add 4 to each side. I get 27 equals 9t, divide by 9t equals 3. So what does this mean? What does S of t equals 23 means? It means after 3 days, okay, 3 days, 23,000 people have the flu. And the last thing we need to do is we need to graph this. And again, this graph, I would prefer to just have a first quadrant graph because we're really going to only use the first quadrant here, okay? So we have our x-axis and our y-axis. We know our x-axis is days and our y-axis is people with the flu in thousands. So this is in thousands, okay? So let's say we have day 1, day 2, day 3, day 4, day 5, day 6, and then we have 1,000, or actually we're going to go more than 1,000. We're going to go by, let's say, 5,000. So it's 5,000, and then we'll say 10,000, 15,000, 20,000, 25,000, 30,000, and 35,000. Okay, so we got to plot our points. Well, we've got a point at 323,000 and 32,000. So day 3, we go 5, 10, 15, 20, 23,000 would be right about there. Day 4, we go up 1, 2, 3, 5, 10, 15, 20, 25, 30, 32,000 right about here. And that is really enough for us to graph our line. We can graph a line from there. We also could say that at 0 days, it says -4 people had the flu. That is a little bit off. It's a little awkward because you can't have -4 people, but they're saying it's just starting below the line. So what I'm going to do is I'm going to draw my line straight out like this. If I can make my tool work. And this represents our people with the swine flu over the number of days. So we can make predictions with functions. We can make lots and lots of predictions with functions. Okay? That's how we interpret functions. And then last but not least, I want to talk to you about domain and range. Domain and range are super easy. Okay? Domain is your all possible x values, and our range is all possible y values. When I say this, it's all possible x values and y values represented by the function, okay? Represented by the function. So we're going to get this copied, and we're going to do some examples for this real quick. So our domain and range is all possible x values and y values. So a great way to look at this is if I have a set of ordered pairs, let's say I have 2, 5, -3, 0, and 4, 11. All right, there's my set of ordered pairs. My domain is my x values. So my domain is 2, -3, and 4. We write domain from least to greatest. So it's going to be -3, 2, and 4. And my range is 5, 0, and 11. So we write that from least to greatest. We get 0, 5, 11. So this is discontinuous data. This is data that's like in little chunks. We have specific numbers. What we're going to say, okay, how do we do domain and range when I have continuous data? Okay, like this graph goes on forever and ever and ever. All right, or this graph goes on forever and ever and ever. How do I find the domain and range? This particular one stops. It stops here and here. So first of all, it is a function. It is a linear function because it is a straight line. It's a linear function. All right, so what is my domain and range? My domain is all possible x values. So the smallest x value as far to the left as my graph goes is -8. My largest x value is 2. So my domain is everything between 8 and 2. Now, we do not want to write all of these numbers. That's a ton of numbers. There's every fraction and decimal value. So what we're going to do is we say it includes the point -8. and it includes the point +2. So we do brackets to show that includes it. And how this reads, it's all values from -8 all the way to +2. Okay, that is our domain. Our range, we're going to do by looking at the smallest y value to the largest y value. So my graph goes down to -5 at its lowest point, and it goes all the way up to +8 at its most high point. So we go, the range is from -5 all the way to +8 included. So that is my range. So it can be any number or value between -5 and +8. All right, we'll do number 4 together. Number 4, this is a function that passes the vertical line test. Specifically, it is a quadratic function. It is a quadratic function. And when I look at this, we're going to start with the domain. If this graph continued, it would keep going forever and ever to the left and forever and ever to the right. Okay, so it keeps going forever and ever and ever. Our domain does not stop. This is continuous. We do not want to write every number that's in the domain because we'll be writing numbers the rest of our life. So here's how we write this. It is from -infinity to +infinity. Our x values are any x value from -infinity to +infinity. And notice I use parentheses here. I use parentheses here because we can't ever touch -infinity or +infinity. We can't ever touch it, so we don't actually include it. All right, our range is from the lowest point on the graph, to the highest. Well, the lowest point on this graph is +2. So it comes all the way down to +2 and it includes +2. So we're going to do a bracket. And then it goes up, up, up to the right and up, up, up to the left. And it's going to keep going up, 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 up. So it's going to go all the way to +infinity, but we don't actually include +infinity, so we put a parenthesis. So the big thing to remember here is that brackets mean included. So basically it touches it, includes it, and parentheses mean not included. So good luck with finding domain and range and function notation. Let me know if you have any questions, and I hope these videos help. Hope you guys have a great day, and I will see you in class soon.